Hello class, in this particular example I am going to show you how to run a regression analysis and all the complementary analyses and plots you need to do that are associated with a regression analysis. And we're going to use PhStat2 for this. Now yes, you can run a straight up regression analysis using the data analysis tool pack in Microsoft Excel. However, all the other stuff like the scatter plot and residual plot and Durbin-Watson test you typically would have to do separately. Using PhStat2, we can do it all in one action. So, a couple things you need to know. We have the data here sorted by week, and that is very important for the Durbin-Watson tests. We also need to know what our independent and dependent variables are. In this particular example, the price of a crude barrel of oil is the independent variable, or our X variable, and our gas column or gas variable is our dependent variable. So with that, we're just going to go to regression, simple linear regression. We need to specify our Y variable, which is the gas column. We need to specify our X, which is our independent variable, that is oil. And we are going to check all these boxes essentially. So we definitely want our regression statistics table, we want our ANOVA, we want our residuals table, our residual plot, our scatter plot, and our Durbin-Watson statistic. We can title this as, say, gas and oil, or oil and gas, whatever you want to call it, and then click OK, and this is it. Bam, you get everything. All along the bottom here you'll see everything you need to do to successfully answer this problem. So the first thing you'll see is the regression analysis statistics, and what you need to pay attention to is the R squared. Okay, that is the amount of variance accounted for in the dependent variable. And we need to pay attention to our slope and intercept because that is part of our regression equation, which you'll see on our scatter plot, which was nicely done for you. We also need to look at our residual plot. And here you see a lot of positive and negative values, which is indicative of an autocorrelation. But then the last thing you really need to look at is this Durbin-Watson statistic. This number here you need to compare to the table values. Now the Durbin-Watson table, there is no lookup or a function in Excel, so you actually have to look at a table. So you can actually look in the back of the book, or you can Google for a Durbin-Watson table online. I happen to have a copy right here. And what this tells us is we have one independent variable, that's what that's k equals 1, 2 across the top here, but then we also have n, which is our sample size. So we have one independent variable, we have 100 cases, so we need to look at these values here, the 1.65 and 1.69. And since there's the lower value first, obviously we need to look at, well, we always look at the DL value. So in this particular case, is our Durbin-Watson value less than or greater than this 1.65? We see that it is less than, so that's indicative of a positive autocorrelation. So another type of analysis might be suggested. And that's it, folks. Any questions? Just ask.